Okay, if we're doing a line integral of f dot ds, what are you doing? You're doing f dot your unit tangent vector, right? And that's f dot, like x prime I plus y prime j dt if you got a parameter t. That's a typical way that that would be written, right? So in this context, and hopefully you've done a number of line integrals and you're familiar with how that works, okay? It would be like this. Because you're taking the negative reciprocal slope, which gives you, this is tangent. To get normal, you do the negative reciprocal slope. And you do it this way, okay? Which is consistent with what you would expect if you're integrating in the positive direction around a circle, okay? And earlier, we flipped the x's and y's and saw that the negative y I plus xj gives you the circulation in the positive direction. Okay? So anyhow, that's your normal, okay? Okay, so again, if this is your curve, well, let's just draw it out and see how it looks. The mechanics are pretty straightforward. It's a pretty good circle. It's an accident. Okay. Here's your circle. And here is like your x prime I plus y prime j. Here's your r vector, your xi plus yj in this case, okay? And this is just for a circle, but we use this for an example. Okay? And this is about to contradict what I said, because you can see here that your x prime would be negative, your y prime would be positive, right? The I component of this vector is negative. The j component of this vector is positive, right? So as I've drawn it, the x prime is negative, the y prime is positive. Just observe it. Just a plausibility argument that can easily be extended, okay? Which means that your y prime I minus x prime j would have two positive components. Okay? Again, x is your component of this vector in the I direction, right? Which is clearly negative. Well, the negative of that would be positive, and your normal vector wants to have a positive j component, right? And it's important to understand this now, because we're going to talk about orientability of surfaces. Not now, but next week. So you want to understand how these vectors work, okay? And similarly, in this case, y prime is positive, so y prime I is positive, so you have positive I, positive j components. Okay? And this is your normal vector. So here's your unit tangent vector, or a tangent vector, and here's a normal vector, okay? Now, usually this would stand for unit tangent, unit normal, and you could divide by the square root, well, the Pythagorean, square root of x squared, x prime squared plus y prime squared, to get a unit vector if you wanted to.
Is it important to get a unit vector?
You can do it either way, as you know, if you do all the problems. Okay? So do the problems, then ask me that. I think you'll understand it after having worked through a number of
Happy
them
Thanksgiving.
and sorted things out, huh?
I'll have a happy Thanksgiving.
Well, you don't have anything due until Wednesday of next week. So if you want to just suffer totally between Monday and Wednesday, it might behoove you to have a little break, or at least take a day or two break. Do something.
Thursday at least.
I'm sorry?
Thursday at least.
Certainly Thursday. Don't touch any of this stuff Thursday. But I'd say I recommend a 2-day break. You come back a little fresher and ready to tackle the rest of the semester, which is,
Gotta clean the house on
well, that's a
Wednesday.
break.
Yeah, and then I gotta eat on Thursday.
Yeah, that's a break for sure. That'll break you. Okay?
Yeah. Maybe
So
I'll be
anyhow,
back at school by then.
yeah, have a break of some kind, as much as you think you can afford. But it just depends what you've done to date and how you think you're going to optimize the rest of the semester. Okay, but do take some kind of a break. You go insane if you don't. Okay.